Welcome everyone to lesson 1 of second semester. This lesson is properties of exponents. Today you will be able to rewrite expressions involving exponents using the properties of exponents. So our first concept you need to understand is just the anatomy of an exponent. You need to know the key features of it. So here we have an exponent, x to the power of m. So the x we call the base of an exponent, and then the m, that is called our exponent. But it can also be known as our power. So you'll see exponent and power used interchangeably. So now that we know the anatomy of an exponent, now it's time to take a look at all our properties of exponents. We have 7 total. Wait. Yeah, 7. I thought I miscounted. All right, the first one is product of powers. So if we have a to the m times a to the n. So as you notice, same base. So when we're multiplying the same base exponents, we add the exponents together. So a to the m plus n. So as you can see over here, we're going to do little examples of each. So here we have y cubed times y to the 4th. They have the same base. So we add the exponents together. So 3 plus 4, y to the 7th. All right, quotient of powers, very similar. A to the m divided by a to the n. So if we are dividing the same bases, we subtract. And the big thing is it's top minus the bottom. Top minus the bottom. So here, x to the 7th divided by x to the 3rd, we subtract the exponents. So we get x, 7 minus 3 is 4. Now, for these first two properties, the base has to be the same. You cannot do these two properties when your bases are different. The base has to be the same to be able to add or subtract the exponents. All right, our next property is power of a power. What this just means is we have an exponent and it is also being raised to another exponent. Think of this as the distribution property. We're going to distribute this outside exponent to the inside exponent. So they get multiplied together. So here, c to the negative 4th times, or to the power of negative 5, we multiply, so we get c to the 20th. Power of a product is very similar to power of power. It's just now you may have multiple exponents to another power. Works exactly the same way. We just distribute that outside power to the inside powers. So this is going to be a to the m times k, and then b to the n times k. So just think of it as distribution. So x to the 5th, y to the 3rd squared, distribute that 2, and we multiply. So this is going to be x to the 10th, y to the 6th. All right, our next one, power of a quotient. Again, very similar. It's just we're going to have dividing in it, but the whole division is being raised to a power. Again, think distribution to the inside powers. So this is going to be equal to a to the m times k divided by b to the n times k. So y squared divided by z cubed to the 4th. We're going to distribute this 4 to the exponent spots. and we get y to the 8th all over z to the 12th. All right, and then our final two properties. The first one is a zero exponent. Any exponent or any base raised to the power of 0 is equal to 1. So any base raised to the power of 0 is equal to 1. So over here, we have a to the 0 is equal to b to the 4th. Well, a to the 0, remember, that becomes 1 now. And then we have b to the 4th, just stays b to the 4th. And then finally, let's talk negative exponents. To be fully simplified, you cannot have any negative exponents. So if you have a negative exponent, we flip it and then it becomes positive. And what I mean by flip it is, this is considered in the top, so we flip it to the bottom and it becomes positive. Or, if your negative exponent is already in the bottom, we flip it to the top and it becomes positive. So here we have d to the 3rd, which that one is positive, and then e to the negative 2. E to the negative 2 has a negative exponent, so we move it down below, and so this is going to be d to the 3rd over e to the 2nd. So now that we have covered all the properties, it is now time for us to go through and do a lot of examples of fully simplifying. So some extra rules for simplifying. When we simplify and we have coefficients in the front, we do what the expression is telling us to do with the coefficients. And then finally, to be fully simplified, there should be no negative or zero exponents. So keep that in mind when you're fully simplifying. All right, so here, let's look at this one. It's straight up multiplication. So we have 6y to the 4th times negative 7xy. Well, the 6 and negative 7, since those are coefficients attached in front, we just multiply them straight out. So we get negative 42. Then we find our common bases. So this x, there's no other x's here, so the x gets left alone. But our y's, we have y to the 4th and y. Remember, when you just have a variable, the exponent is 1. So y to the 4th, y to the 1st, we just add them together. So we're going to have y to the 5th. We have no negative exponents, no zero exponents, and no bases that are the same. So we are fully simplified. All right, our next one, 5x to the 4th, y to the 4th, 2x to the 3rd, y to the 3rd. So again, we start with just multiplying 5 and 2. So we get 10. Now let's look at our x's. So we have a x to the 4th and an x to the 3rd. So we add those two together. 4 plus 3 is 7. Now we look at our y's. We have a 4, we have a 3. So we add them. So y to the 7th. All right, now let's try some division. So here we have a number in front on the top, no number in front on the bottom, so it's just going to stay 25. All right, now our x's. We have 7 and 1. So again, we're dividing, so we subtract. 7 minus 1 is 6. And now we do the same with the y's. 3 minus 2 is 1, so we're just going to leave it as y. All right, last one for this page, and then we have a plethora of more in the next. So here, again, we look at our numbers. We can't take 3 divided by 27, but we can simplify this as a fraction. So we can take this 3 over 27 and write it as 1/9. So now for our x's. We have x to the first and 2, so 1 minus 2 is going to be x to the negative 1. And then we have y to the 5th minus y to the 4th, which is just going to be y. But as you can see, we have a negative exponent here. We cannot have a negative exponent as a final answer. So what we need to now do is take this negative exponent and put it into the bottom of our fraction. That's right. That's why we have a fraction here, top and bottom. Put it into the bottom. So in the bottom, we're going to have 9x. And then any positive exponents stay in the top. So y is going to go into the top with that 1. All right, that's the end of our first page of notes. Make sure to click into the second video to watch the rest of our examples.